support prospective teachers learning mathematics. So I'm the director of the Center for Research in Math and Science Education here at San Diego State, and it's an interdisciplinary group of scholars from the College of Sciences and the College of Education. And so a question to think about is, what is it that math and science educators do? It took my dad a long time to figure that out. I'll answer that question with an example from my own research tonight. And I thought we would start with this question, which is important both for society. If you're running a school, you need to think about what your teachers need to know. And it also turns out to be a richly theoretical question in our field. But before I proceed, I think we should first take a moment to consider, what do we mean by mathematics? So these are 4 common examples of school mathematics. Most people view mathematics as a set of facts to memorize and procedures to learn. And that's certainly a part of what mathematics is. But it's really so much more than that. It ought to also be a set of concepts to understand and ways of reasoning to develop. All 4 of these could be solved through focusing on reasoning, but generally students learn how to apply a particular procedure to each of these instead of ways of reasoning about them. And we pay a price for that approach. So some data from the National Assessment for Educational Progress: 13-year-old students in the United States were asked to estimate 12 13ths plus 7 8ths. One way to think about this is that 12 13ths is a little less than 13 13ths, which is 1, and 7 8ths is a little less than 8 8ths, which is 1. So the sum should be a little bit less than 2. The 2 most popular responses were 19 and 21. The correct answer came through in 3rd place. One was responded by 14%, and another 7%, I suppose they also answered correctly. And I would contend that the way that many students are thinking about this is as 4 separate numbers, and they're asking themselves, what is it that I have to do to operate on these and get the right answer? The National Research Council published a pretty interesting view of mathematical proficiency. It's one that's been pretty well cited, and in fact the Common Core state standards that many of you have heard about draws from this. I won't go into details except to say that by this view, mathematics is an integration of understanding concepts, of being fluent with procedures, of having ways of reasoning and justifying your reasoning, of being able to solve problems. And the last one, and I'm going to take just a moment on this, is called productive disposition. And I'd like you to think about the extent to which this was explicitly addressed in your elementary education. The tendency to see sense in math, to perceive it as useful and worthwhile, to believe that steady effort in math pays off, and to see oneself as an effective learner and doer of mathematics. I'll share with you one of my favorite examples that I think relates to mathematical disposition. Many years ago, I was working with a group of prospective elementary school teachers. We were out in a school. We were preparing to interview 2nd graders. And in preparation, I asked them to provide the task 70 minus 23, and I told them that some of your students might answer this 53. And we discussed ways we might invoke some disequilibrium in the part of the students so that they might rethink their answer. We decided that this might be a nice follow-up question. And after the interview, one of my students came in and said, I did this, and I gave the student 70 minus 23, she got 53, then I gave her 76 minus 23, again she got 53, and then I said to her, well, that's interesting. Here you have 70 minus 23, and here you have 76 minus 23, and both gave 53, to which the student responded, yes, math is like that sometimes. And I would contend that for many, many students, math is always like that, and that is really a shame. So let's take a look at, in thinking about this question of the knowledge that that the teachers need, let's take a look in the schools, and we're going to watch this child named Javier, who is in the 5th grade, been in America for about a year at the time this clip was taken. He is thinking about how many eggs are there in 6 dozen. So 6 dozen eggs.
You know how eggs come in a carton?
Yeah.
And they're usually
12, yeah.
12 in there? How many eggs do you have if you have 6
Okay, 6 and 12. That would be. 72. Because when I say 5 times 12, that equals 60. If I add 12 more, it will be 2, 7.
How did you know that 5 times 12 is 60?
Because 12 times 10 equals 120. And if I take the half of 120, that will be 60.
So it always makes my heart sing when I watch a student actually make sense of something in mathematics. And Javier clearly was making sense. I don't have time to unpack all the mathematical ideas that he was applying, but this is Randy's representation of Javier's thinking. I wouldn't suggest that he would write all this, but he was invoking properties of mathematics. He was invoking a deep understanding of place value. And the question underlying all this is, what is it that a teacher would need to know to understand Javier's thinking? And where do teachers learn this? So this was at the foundation of the research project that I was involved with. And the problem that we addressed was that, so at San Diego State, we offer some math courses in the math department designed for prospective elementary school teachers. They're very well designed. I know some of the people who played a big role in designing those, and many institutions offer these. The problem, though, is even when students attend thoughtfully planned math courses, they often go through these courses in a perfunctory manner. They don't seem to value the experience. And I suspect that for many of them, they have a complex system of beliefs that supports their not valuing the learning of the mathematics. So for example, imagine somebody thinking this. I'm a college student, and if I don't know something, then children wouldn't be expected to learn it. And if I do already know it, why would I need to learn it again? And so to shake this up, one of the things that we thought about was, can we help prospective teachers focus on children and use that as a foundation for getting them interested in the mathematics? And so the way that I think about this is that when prospective teachers look at mathematics through the lens of children's thinking, it helps them care not about the mathematics as mathematicians, but as teachers. So we actually carried out this very large experimental design study, we being people in the math department, people in the School of Teacher Ed, and we compared prospective elementary school teachers in math courses, some of whom learned about mathematics, children's thinking, some of whom did not. The results were that those who did learn about children's thinking improved their mathematical content knowledge, and they developed more sophisticated beliefs. I will share one slide of data. These are beliefs, and to highlight how these play out, the CMTEL and V means Children's Mathematical Thinking courses. It doesn't matter. The more S's are observations of classrooms. S means select classrooms. C means convenience classrooms. These tended to be more traditional. The control group did not have any of these experiences. You'll notice that the beliefs changed the most for people who were focusing on students' thinking. And a particularly interesting secondary finding was that the people who didn't go to classrooms actually had their beliefs change more than the people who visited traditional classrooms. In other words, we have to be very careful about the experiences that we're giving to people. The results of all this have led to some practical implications. We have a children's mathematical thinking course that we now offer here at San Diego State. It's a hybrid course between the math department and the ed department. We developed a searchable video database that's being used around the country. several research implications. We developed a belief instrument, and this work has led to studying professional development as well as teacher noticing. And I'll end by leaving you with 5 takeaways. Elementary mathematics, understood deeply, is not elementary. Our biggest long-term problem related to math teaching in the United States is not how we teach, but that we have no way of getting better. We do not have a systematic professional development approach here in the United States. Teachers can learn a great deal from teaching, but most have to learn how to learn by focusing on students' thinking. This doesn't just naturally occur. And finally, teacher preparation is critical, and sustained professional development is also critical.
Questions for Randy?
Yeah, so of course, scores of students in mathematics are a lot better in many other countries than they are here. Is that because of better teaching, or some of the ideas that you're discussing being applied in other places?
Yeah, the data looking across nations is complicated because in the United States, even if you go to a high school, a comprehensive high school in the United States, it's almost like you're visiting 3 or 4 different schools in one. You have a group of students who are college-bound with an interest in the sciences. You have a group of students who are something in between. You have a group of students heading in a different direction. I'm not arguing it should be that way. I'm arguing that's sort of what's happening in the schools. And the aggregate data does look often of concern in the US. On the other hand, if you break it out, I don't think there's quite the concern that a lot of us have. I do think that in the United States, we're much more comfortable allowing groups of students to sort of go in directions that don't necessarily propel them. The Common Core state standards are supposed to address that. That's going to take a little bit of time. There are practices that are different. I mean, for example, in Japan, the teachers teach less than half the day, whereas our teachers in elementary school teach all day, and they have professional development built into their day. That's a major difference and a major commitment between how they're running schools there and how we're running schools here. So.
What's the essence of the, is this on? I don't think this is on, is it?
He doesn't have.
It's taping in the back.
Okay. What's the essence of the difference of the controversy over the core curriculum, is it called? No.
Common Core.
Common Core. And what do you see as the resolution of that controversy?
So I suppose anytime we change curriculum in a country, you're going to have huge adjustments. I think one of the concerns about the change is that there are always groups of students who have been succeeding in the system that was in place before. And so I think there's always concern that those students might not continue to succeed in ways that they did before. So that's one concern. I think a second concern is that whenever you change something, so the Common Core state standards is designed to support students in trying to make a little bit more sense. So in theory, I'm behind it. In practice, you can't change teachers' approaches and ways of thinking about math just by changing the curriculum. That takes a long time. And I think that the Common Core state standards is not going to automatically change how people approach the teaching of mathematics. So I think it's going to take a little while. I think teachers have to have some time to grapple with it and to start thinking about it a little bit differently. And I think we also have to be aware that no matter what we do in schools, there will be people who will be in favor of it and people who will be opposed to it, and we just sort of have to make sure we can hear what people are saying as we still continue to proceed.
Are all the new graduates coming out of schools of education in mathematics teaching sort of, are they on board with? with Common Core?
So the Common Core state standards hasn't fundamentally changed what people like I do in preparing teachers. In fact, most of the people I know who do what I do have been teaching in manners that were consonant with that for many, many years. What it does do, it provides them a context outside that continues to support thinking about mathematics in a little bit more conceptual way. So, but whenever you ask a question like, are all the graduates, I can answer that right away, no. There's never anything that all the graduates, but they all know about it. And I think they're all trying to make sense of how they can support students in trying to understand the mathematics.
I'm going to invoke the last question with executive privilege. That means you have the microphone. My daughter's now teaching in a really impoverished school where the issues are really homelessness, or the children aren't able to wash their clothes, and those level of things. How do you adjust the kinds of advice you give? Because obviously you move from whatever, La Jolla at one end down to this spectrum, are those principles so consistent that it doesn't really matter?
I started my career as a teacher in Liberia, West Africa. They were impoverished as well. I think that the notion of making sense of the world is something that, it sort of goes back to some of the issues that were discussed in the first. It's something that I think humans are always trying to do. Now, clearly, the social issues of people coming to school hungry or students who can't do homework because they have other issues are huge. And I think teachers teaching in those environments have to struggle with those. But I don't think there's anything different about what the students are capable of doing. I think that there's something different about how we have to bring them to the table and connect to the lives that they're leading.